For this RStudio video tutorial, we're going to look at how to make scatterplots in R. Scatterplots are a way to represent two numeric variables which come from the same data set and their relationship to one another. Typically, scatterplots are made in conjunction with a correlation or regression analysis. However, many of the functions and arguments we'll learn about in this tutorial can be used to plot other different types of plots as well. So I've already loaded the data frame that we'll be using today into RStudio. It's called wine. Let's go ahead and briefly examine it using the head function. We see that there are 5 columns, 4 of which are numeric, and the first is categorical. Since we are doing a scatter plot today, we're going to need to plot 2 numeric variables against one another. I'm going to choose alcohol content and malic acid content for this. So in order to make a scatter plot, we simply use the function plot. The first variable we provide will be the one on the x-axis, and the second one we provide will be on the y-axis. Today I'm going to put malic acid on the x-axis. So wine, malic acid, and then on the y-axis, wine, alcohol content. So we do see a plot appear. There doesn't seem to be a clear relationship between malic acid and alcohol content, and this can be fleshed out and quantified with a regression analysis if you would like to do so. Something very clear to us that we see from this plot is that the axes are not properly labeled. R does automatically label the y-axis and the x-axis with the full name of the vector provided to plot it. However, this is not the ideal way to label our axes. So let's go ahead and add proper labels with xlab for the x-axis, call it malic acid content. Ylab will be alcohol content. And the main will be characteristics of wines. And here we see a properly labeled plot. There are a lot of things we can do to tweak the various parameters of this plot if we like. One thing we can do is change the length of the x-axis and the y-axis. So R automatically picks numbers for the lengths of the x and y axis. For instance, this goes from 1 to 6 and this goes from 11 to 14. However, you can manually change these numbers using xlim and ylim. So using xlim, I'm going to change it from 0 to 8. Notice how I have this C here. That's really important to include. If you don't include that C, you'll get an error message. What it's telling R is that these two quantities should be considered together. And let's add ylim to go from 10 to 15. And here we see the plot has changed, 0 to 8 and 10 to 15. R may have been a little more correct in assuming how long it wanted the x and y axes to be, but this works just the same. Something else I might want to do is change the type of point I have. I can do that with PCH. If you just Google R PCH, you'll see lots of various different types of points. For instance, you can have a star, a triangle, a square. Today I'm going to do a closed solid circle. The code for that is 20. So now we see we have the same exact plot, except the points look slightly different. This is just an aesthetic choice and is not necessary. I could also add color to the points using COL for color, and I'm going to make them all red. Also now we see we have characteristics of wine, malic acid content, alcohol content as before, except all the points are red solid circles. Something else we can do is change only some of the points in the plot without necessarily altering everything. In order to do this, we use the function points, which tells R to edit these points but leave the rest of them the same. So for instance, what if I wanted to change the color of just cultivar 1 wines? For this, there are 3 cultivars in this data frame. What I would do is say points, wine, malic acid, where wine cultivar equals cult1, wine alc cont, where wine cultivar equals cult1. So we're still plotting x against y, except we're specifying we only want to deal with points which are cultivar 1. Again, we need to set their PCH equal to 20. But let's say we wanted to change the color of the points. I could make these points blue. And now we see some of these points on the plot have changed to blue, whereas the rest of the points have all stayed red. What we now see in this plot is that only cultivar 1 points are blue, whereas all the other red points are either cultivar 2 or cultivar 3. We can further flesh this out with a second points command. I'm just going through these commands in R using the arrow keys, which is a convenient way to direct yourself through all the commands you've previously typed. I'm going to change this to 2. So we have cultivar 2. And I'm going to change that to green. Now we see 3 colors of points on our graph. We see blue for cultivar 1, green for cultivar 2, and the remaining red at this point all refer to cultivar 3. And this concludes our RStudio video tutorial on scatterplots.